Okay, so let's get on with today's work. This is 2 variable data. What number are we up to? Number 6. And it's the last lesson in the unit. So this one's going to round out our statistics work, and then we're going back to Algebra 1 stuff right after this. So this week you'll have the last lesson on stats, and then we'll roll back into, I think it's the zero property or something. We're right back into algebra. Why do you want some stats right now? So you can kind of get a taste of it. This is definitely stats light. There's a lot more math and statistics, but I think this is maybe the fun part because it deals with sort of the big picture of what statistics is. And statistics is very valuable to you in all 3 of my degrees, engineering, business, and education. There was a stats course, and it was different. It was it was stats for engineers, right? You're talking about the failure of parts. It was statistics for business. You're talking about data from sales and what that looks like, right? You know, if you're Walmart and you've got shelves to fill globally, if something stops selling, so here you put a new pair of jeans on the shelf, right? And it ramps up like this and starts selling, but all of a sudden starts to flatten out and goes like this. When do you want to take the jeans off the shelf and put some new product on, right? When do you want to do that? So that was statistics for business. And then education is, you know, how are students doing? How does their performance look, right? What's happening with different student groups? Is there something we can adjust to better address the needs of different student groups so that all learners can engage, right? So you see, you get the idea. Statistics is very applicable to whatever subject you're going into, is where I'm headed with that. All right, this one is exponential data. And I like it that it's at the end. It's the last lesson because it really does roll back into algebra now. So we'll go to desmos.com, so get your device ready. I'd like you to type some in. And let's talk about this. Under what circumstances will data accelerate, and how can such data be grouped? All right, there's our essential question. The spread of disease. What if one person infects 2, each of those infect 2, and each of those infect 2 each? You can see that after only a few generations, a lot of people are sick, right? And some of these different variants we have are even more potent or more viral or spread more easily, right? So instead of one person infecting 2, it's one person spreading to 10. And then each of those 10 spreading to 10 each. Are you with me? The whole world could be sick in a matter of stages, right? Because it spreads so easily, right? And so there's different diseases and they have different spread rates. And you guys are very familiar with that right now if you're watching the TV at all, right? We've been living through this kind of experience. Okay, so that's what exponential is. What does it look like? So it looks like this. You've got your 2 variables, right? 2 variable data being, let's say this is time. There's 1 variable, and let's say this is number of people sick. All right, so it starts out slow, right? Here's all the data. You don't even notice it, right? It's there all along, but we don't know what's happening. Remember even back in that November period where we found first people sick with this new virus. Nobody knew about it, but they were among everybody all along, right? However it got into the population, we're still arguing about. We don't know, I don't think, right? Did it leak from a lab? Did it come from some, we know it's an animal virus, but how did it get from the animal to humans? Somewhere in there, we lost track of what happened, right? Maybe someday we'll know, maybe we won't. Right? So at some point, though, this thing starts affecting humans. And what happens is, as it starts to go through that spread, it starts to ramp up. And at some point, it starts going vertical. Almost, right? Not quite all the way vertical, but basically like a rocket ship, right? This thing, we don't notice it at first. All of a sudden, out of nowhere, it's off the charts, right? Everybody's sick. We have a pandemic, etc. So that's the curve. That's what it looks like. It's so dangerous because of its out of nowhere kind of, we're all caught off guard. And you see us, as humans, we can think, we're rational, we have science, we're modern, all these things, and we're still just as kind of clueless, so to speak, as we roll through this pandemic, right? You see all the different variations of what's happening now. We don't know. It's a new one. We don't know. We're looking, right? So all that plays into this. So the graph is called exponential. I like this. It's kind of a play on words, I say. This is an exponential graph. Because the variable x is in the exponent position. What does that mean? What does that look like? All right, so exponential. So we have something like this. Y equals some number, which is the base. So let's start with the most basic exponential equation. It's 2. Where's the variable x? It's in the power position. All of the equations you've dealt with before exponential, the x or variable was in line, right? It was down at the normal position. It was not in that superscript. Superscript is up here in a power. It means it's this number times itself that many times, right? X times. And that could be wherever x is, right? Wherever this is going through the cycle. So I think the best way to look at this is to go to desmos.com. So if you're willing, go ahead and go to desmos.com. And I'm kind of thinking, I'm kind of thinking to move this down here. And Lizette and Viri, will you guys see if let me pull up Desmos and see if, I don't even know if you can see what I'm doing, but see if you can see what's happening. All right, what is Desmos? This is the graphing calculator that's very practical, and you should definitely be aware of it. It's desmos.com, which you can't see up there. desmos.com. Can you guys see that from there? Okay, thank you. And so we're going to that site. There's right here in the middle a graphing calculator. It's free to use and it's so much fun. More fun than graphing by hand, at least, let's say that. So I'm going to click the graphing calculator. And now let's go ahead and put in that first exponential equation. We have y equals, and you can't see me doing it, but I'm going to, maybe I'll use the keypad so you can see it from here. Is that in there too, Gary? So see this caret, where is it here? Here. This, either one of these will raise to the power. This will square it, this control right here. This will raise it to a variable. So I think I actually just use the caret key on mine, which is Shift 6. But you can also click this, that raises it up. Notice it went to a superscript, and there's the x. And let me move the keyboard. So here's the equation we're looking at, right? This is, or here's the graph we're looking at. Notice it's way back here. We don't notice any change, and all of a sudden it's exploding up. This one always passes through the 1 on the graph. This is 5, 4, 3, 2, 1. So it's passing through here, on up, and notice it's headed toward this idea of vertical. Now it never ever gets vertical, but it gets close to vertical, ever closer to vertical. The idea being it's accelerating very quickly. Then there's some fun aspects that Desmos lets us do of exploring the exponential curve. So this would be a disease which is spreading. We could also have the effect where something is decreasing in an exponential manner, right? So let's take y equals x up to, caret, I'm going to use the caret just for quickness, minus x. So here, notice the curve. It's something with a lot of action going on, and as it proceeds over time, it is now diminishing all the way to near 0. Now again, this is the same type of concept where it's ever approaching 0, but never reaching it. And maybe just to explain that for a second, how can this happen? Okay, hello, morning. Okay, so take a distance, right? Go this much. And let's say we're going to now take this distance and cut it in half, right? And we go to here. And now we're going to take this distance and cut it in half and we go to here. And now we take this distance and cut it in half and we go to here. Now my hands are physical, so they have thickness, right? But imagine lines, and lines have no thickness. They have no mass. So imagine the ability to ever move half closer. Do you ever reach the other side? The answer is no, because there's always some distance, no matter how infinitely small, there's still half to go and half of that and half of that. Do you get this? Right? In the, what was the movie about Einstein? I'm forgetting the title right now. Where the two main characters were attracted to each other. They're talking about the physics concept of, if you're here and I'm there and I can only move half the distance, I can never reach you, right? But the funny thing is they're physical, so they could reach each other, right? Anyway, it was romantic comedy, right? But that's the concept. So this graph is ever getting closer to zero along this line, but never reaching, right? And then let's talk about the theoretical concept of exponential, because we're talking about physical situations versus theory. We can also continue to add, let's add another one here. Let's say y equals, now let's make the 2 negative. Negative 2 raised to the power of x. This one's going, accelerating down in the negative direction. It becomes harder to find physical examples of this, right? So we can't use an infection anymore on this because it's down in the negative area. So negative may be a direction in this case, but it's not as practical, and in fact there's no physical examples of it. Now you're into a theoretical concept, and likewise with this one, y equals negative 2 raised to the power negative x. It makes a cool geometric shape when graphing. And remember the cool thing about, another cool feature of Desmos is you can turn these off. I just want to look at this curve, so I have 4 curves in there, but I can highlight one or the other, or I can highlight 2, I can turn them off, and I can compare those. So if you're learning to graph, which we did in prior years, remember we had to spend hours plotting points. Now you can just open up Desmos, put those graphs in, and remember a lot about the different curves quickly. Okay. So with that said, let's review and see what else I've got. Go to Desmos, and basically that's part of the lesson in this one, and the homework is for you to go and practice these on Desmos, and in addition to the school. So exponential graph to the power x, exponential data / graph, y equals 2x is your most basic. And then the spread number, just to, let's show one more thing while we've got this up here. Let's go back to Desmos. Let's clear out this one, and this one. And let's adjust the base. Y equals, so this would be a disease that spreads more quickly. Let's turn on the 2x, there it is right here. And now let's go ahead and say, what if this goes 3 to the x? Notice this, the color of the line is black here versus red. What is happening with the black one? When the base increases right here from 2 to 3, it's spreading more quickly. See it here? Likewise, if you start to say y equals 10 to the x, you can now expect that that will accelerate more quickly even. Likewise, if you play with that base and say, let's make it 0.5 to the x, and let's do this in a parentheses so it can think, get this right, come on. Okay, here, let's try it again. Let's do y equals parentheses 0.5 caret x. And 5.5 1/2. Well, I'm going to go into that later. Let's leave it with this just for the moment in terms of our introduction. For the 2, 3, and 10 to the x, how the increasing base is talking about a more spreadable virus, right? This would be the original COVID-2. This would be the Delta variant 3, and this would be the Omicron variant 10, right? Illustrating the difference in how those lines increase. Okay, I don't want to get too far because we'll be outside of it. So let's stop with that one.